So in the last video we were looking at these basically these 2D printouts of the board layout, but actually to heck with that, I got the real thing now, so let's take a look at the real thing. So I've made some changes since I showed you those paper layouts last time. A couple of the changes I made is that, well, I didn't like the idea of the wires kind of wrapping around all willy-nilly around the outside of the board like that. So I actually drilled holes in the boards for the wires to go through. So the wires will go from these connectors through the holes down to the holes below, and those will be soldered in. As well, I didn't really like the idea of soldering bare wires in. So what I have here is I have these wires with basically wire turrets crimped onto them, and those are the perfect size to go into these holes to be soldered in, so that should provide a really strong connection. So you can see the spacing on the board here. It's about 5/16 of an inch between the two boards. There's our copper bars, and then underneath is the aluminum bars that actually I have trimmed to size now. I did just cut them with a hacksaw. It really wasn't that hard. So I thought I'd just show you this here. So you notice that the top board is actually longer than the bottom board, and the reason for that is the current sensors. They actually mount to the underside of the board right here, and they go right here. So the copper bars go right through them in that spot there. So that's how that's going to work. What else can I show you here? This capacitor I just kind of have floating on here willy-nilly, but you know, they all snap into the holes and everything. So that's all very well done. Perfect layout there. So I'll show you what's underneath here. So we remove the top board, and here's our next board down. So these copper bars just get to sit on these areas of the board here where I've removed the solder mask. So you can see this area of the board is all tin in here. It's all a straight connection to the board. There's no insulating material in there at all. So that'll provide a direct connection to the board. Now you'll see all these holes in the board, and that's where I'm going to have all those bolts going through for all the ring terminals. So I still need to drill out these copper bars as well as the aluminum blocks underneath. And I'm going to tap those aluminum blocks underneath because the screws are just going to thread right into them. And that's going to sandwich this whole thing together. So I need to do that, but I need to do the mechanical bit before I get to soldering this at all. So unfortunately I won't be able to build up this today. We'll be able to solder up the control bit of it today. I think I'll just do this section here, verify that this works, and then if that all works, then I'll populate the capacitors here, because there's no use populating the capacitors if something's wrong over here and that screws up the whole design. So yeah, these are actually quite big boards. These are some of the biggest boards I've ever had made. They're 5 inches wide by, this one's about 8 inches long, and I believe the other one here is about 9 inches long, give or take. So they're pretty beefy boards. Now, how I actually sent these to the manufacturer, I actually got 2 copies of the board. I actually sent it like this. So it's actually one big, huge board going across like this. Let's see if I can show you what this looks like. Alright, here we go. So basically it's just one big board that I've drilled some holes in the middle here and placed 2 silk lines on there so I know where to cut the board. And the reason why you do this is because, well, it's a lot easier to send one file over to the manufacturer as opposed to 2 sets of files, and as well it usually comes out much cheaper, because then, you know, of course the manufacturer doesn't have to handle 2 boards, they can just handle 1 board. So all I did here on these other 2 boards is I just cut them in half, and that took all of 30 seconds. Extremely easy to cut with those holes there. It just guides the saw and then just file the edges smooth and you're done. So basically these aluminum blocks here, I trimmed these already with a hacksaw. The side I cut with a hacksaw here, the dimension is not critical. It's really not that important. It just needs to be small enough so that it doesn't interfere with my design here. So you can see this represents the back side of the MOSFETs here. So this flat side will be going right against the MOSFETs here like this. And of course the bar just has to be narrow enough so that I can still populate these things over here. And there's actually a lot more space than it looks here. I'm just not lining this up correctly. So something like that. Same thing with this one over here. It just goes on to the next row of MOSFETs up here. And of course there needs to be enough space on the board here for these components down here to be populated. So that's essentially it so far. I ended up cutting these differently than I said previously. I said I would make them 1.5 inches tall by 1 inch wide. Well, I actually decided to make these 1 inch wide by 1.25 inches tall, just to lessen the height of the controller a little bit. And I might actually, instead of this 1/8 inch plate here, I think I'll probably end up using 1/4 inch plate, a bit thicker, and I think it will it'll spread out the heat throughout the plate quite a bit quicker and hopefully dissipate some more heat. So that'll keep everything running a bit cooler. So yeah, that's the status of this so far here. I think I'm just going to populate up this control board. I've been aching to populate this thing up because just been really excited to get this thing going. So I'll let you know how that goes. So here's just a quick overview of the boards. Got B- on the bottom here, with a couple holes for the temperature sensor wires, which I also didn't mention yet. These here are actually going to be jumper wires, 12 volts to 12 volt, ground to ground, and PWM to PWM. Same thing up here. Up here I have B+, along with some more temperature sensor holes. Now I did make one minor goof here. I apologize for the shaky camera work, by the way. It's much easier for me to just freehand this than mount this on a tripod or anything, because I'm changing views all the time. But I originally intended these holes to be for this Belden cable here, the shielded cable, but I kind of goofed and I made the hole a little bit too small. But not really a big deal, because I've just decided to make the temperature sensors with these 3 smaller wires here, and those fit through the hole no problem. And of course the shielded cable is a bit better for noise and such, but I don't expect there to be much noise on the temperature sensor cables, because everything's isolated, so all the noise should be common mode anyway, so it should be fine. Here's the top side of this board. Once again, same thing, B- here, attached to all the negatives of the capacitors, and B+ attached to all the positives of the capacitors. These holes right here, here, and here are for the little mounting nylon studs I have to separate the boards. Here's the DC to DC converter section, the control section, with a whole bunch of resistor divider networks and capacitors here. Now the back side of this board, it's actually pretty interesting as well. Here's where my current sensors go. Here's my opto isolator for my PWM signal, and a couple more discrete capacitors and stuff for filtering. And these here, these are actually interesting. These say 22 nanofarads. Those are actually for capacitance between the 2 grounds of the isolated DC-DC converters. So I'm actually using 1 kilovolt capacitors there, and that helps reduce the output noise on the DC to DC converters. The bottom side of this board, mainly just all the MOSFET driver stuff. You can see it's all very, very close to the MOSFETs themselves. There's almost no space. That loop there is extremely small. It's pretty much as small as I could get it. So yeah, I'm going to populate this up, the control side at least, make sure it works, and then go from there.